Welcome to our third session on Timescale for Finance. And today we are going to talk about tracking last price. So my name is Jônatas. I am developer advocate at Timescale and also community manager. And we are doing this as a call to action to our community, as a way that we can aggregate value with the community and try to understand the standards, how people think. And maybe we are going to also introduce a template that can be shared and can easily make more adoption in a specific segment. So now this segment is finance, and this is our official repository. So you can just take a look on what we have there. And in the next Wednesday, we are starting same initiative to go about sensors data. So if you are interested on this sensors data, feel free to join us next week as well. So I'm going to just have a very short overview of what we have in progress and what we already have here. So that's our first opinionated template for finance. We are trying to bring everything as modules that you can just embrace or just let them like disabled, and it will not affect any performance, right? So, and what we are trying to cover, especially on finance, is market data streams. So we are talking about trades or ticks. And in this case, I'm calling the table ticks. It's like stock data. And you basically have like a stock symbol at some specific price being traded in a volume. And that's like the basic structure. And this is the hyper table. This is the table that we are using to be, let's say, partitioned by 1 day. And we also have compression. We compress and segment by symbol. And we also have 1 week compression policy. So we end up compressing this later. From the processing pipeline, we also have hierarchical continuous aggregates that allow us to have these multiple time frames that you can roll up over the previous time frame, and you can save a lot of processing. And that was what we covered in the previous session. And today we are going to talk about tracking last price. So it's very common that you want to check the last price of some specific stock. So how you are going to do that? You have a very huge stream. Sometimes you have like 10 events per second. Sometimes you have dozens of events per second. And these events, they are streaming. So how you guarantee you are getting the latest on one? So you can do in several ways. So that's what we are going to do today, and that's how we are going to start. We are going to especially focus today on the trigger part, but we are also going to cover alternatives. So the business requirement is access the latest price from a stock. So I just want to go, I'm watching sometimes hundreds or thousands of prices that from the stock, and I have 2 options. I can cache it, or I can query it for the raw hypertable and find the results. So if I cache it, I will basically store it on a metadata table, while if I query it, I will just be doing it on demand, depending on how much user is requiring, or other systems are requiring this information. So it's very important to check and understand your business requirements here. Like, hey, do I really need the latest price? Do I really need to get like for all the stocks all the time, so frenetically updating it? So it will depend on this very basic strategy, and that you will eat more or less CPU, and you will be needing more or less processing power. So all these decisions impact the performance of your business and the size of your data as well, right? So let's dive into this. So this is the ticks table. So this is a very simple table, and you can see here the symbol. The symbol is just a text. It doesn't contain anything special. And now with the trigger, we end up creating a new table named symbols. And this symbols table is our metadata table. So there is a very simple, straightforward table that will be like a materialized view for us. It will just contain a subset of records that's like symbol is the primary key, and then you have last price at to know the timestamp of the last price. Okay. In the other side, we have the trigger that we need to update. So we have this function, and you can see the function here that it contains a where symbol equal new symbol. So it's just an update thing. So why we make it as just an update and not an upsert? Because then we can control the critical mass of symbols that we want to watch in our metadata. So let's say, for example, you have like 2,000 symbols or like 1,000, or generally like a small market will have like dozens or hundreds of symbols, right? And then you can also combine them and end up with new combinations. So in this case, we are just watching and trying to update symbols that already exists there. We are not going to upsert new lines in this table. So this is a tricky thing of our benchmark today. So the idea here is how we can learn a few from this small perspective of slicing the critical mass and checking percentages of symbols that are there or not. Okay, in the other side, you can just do a select, right? So how much costs this select? Why the select would be would not be a good idea, right? So Timescale did several improvements on this type of like getting latest record from your data. And the main point is how you are going to trace back the query plan to execute it. So I was testing it a few minutes ago just to confirm like what I'm saying here, and I will just scroll to my terminal here just to let you understand what we are talking about. And here you can see a few things here. So the first thing that I would like to show you is that we are in this database, which we have 54 million rows. This is just like because I'm doing several benchmarks over and over, and I'm just appending new data and checking it. And then you see here is the common thing, like I would like the price of a specific symbol and just get the latest one. And if I enable time here, you can see it's like 154 milliseconds. And here you can see the query plan. I started analyzing query plan for this case. And you can see here, this query plan, you see something here saying rows removed by filter, and then you see, oops, let me just reduce the size here. Then you can just see, yeah, you can see here, never executed. So it just needs one row. It just needs the order by time. So it can go to latest chunk and can get it there. But depending the volume of data, you will be competing resources and reading resources. So maybe you will scale, read replicas, and use another alternatives. So this is just like one thing to keep in mind. Sometimes it looks fast, but if you are querying hundreds of symbols all the same time, maybe it will not be very optimal. And that's one thing that like Timescale is evolving to the point that will not need metadata table, but this is an alternative. Sometimes you just use it for convenience. Sometimes you just find a way of doing this. So this is an alternative. This is a discussion. It's not like a good practice or a bad practice. This is just like an alternative of building things and how you can make it. Okay, so moving back to our scenario here, we have this trigger benchmark. So that's what I built for today. And this is the trigger benchmarks here is basically this small function that we start, that is the add_ticks function. So add_ticks function is a function that just appends data. So you can see here with latest as materialized. So it means that it will go find the latest time and just append something in the end of the hyper table. So it keeps doing that. And I'm not considering like the time of querying this, because like this is also with latest as materialized as a way that you just execute it once. But the main important thing here is that we are inserting 500,000 rows. So we are executing 100 milliseconds every tick, and we do it like, for example, 900 symbols. So we have 1 minute of data, so we have 500,000 events being inserted. And this is a single batch, right? So this is a single transaction, everything in one shot. And then you remember that it will be executed one-to-one. So every time you execute one update or one insert, it will also trigger this on the ticks. So for every symbol, we are updating it 10 times per second in the timestamp from that symbol, right? But we are trying to insert this 500,000 as fast as we can, right? So let's move on. And just remember, we are in a single batch, single connection, single process, and we are server side only. What it means? It means that we are not like creating the data in a CSV in my computer and sending it through the internet. We are using a SQL command that generates series, that generates the data inside the server and just make it go to the database, right? So we are just cutting down the process to have to narrow down a very, very simple step. So it's a single CPU processing. We are not parallelizing anything. We are not trying multiple things. We are just trying to isolate the minimal unit here. So let's review the code. The code is available. You can find it on github.com/timescale/templates. And if you find the finance folder there, you see this benchmark trigger. That is the code that we are going to see now. So let me move here to the terminal again, \E to edit benchmark trigger. And you can see here that we have timing on, and then we have the add_ticks function. And then that's how we start our benchmark. So we drop the trigger. No trigger. Let's truncate the symbols table. We don't have any symbol, any table, any rows in the symbol table. So we are not tracking anything. Nothing is there. We are not validating things. And then we just add trigger, add ticks with no trigger. So that's like insert 500,000, no trigger. Let's see how much it costs, right? Then we add the update latest price trigger, and then we add ticks, but we don't populate the symbols. So if we don't populate the symbols, we are just inserting, and then it will try to update, but we'll find nothing. So it will be trying, and nothing will be updating, but it will have the process to go there and trying to update, trying to find the index that's similar, and then go over, right? So that's the next step. Then we get like, let's let's now we have the trigger. So let's truncate the symbols and let's go and insert some symbols. So what we do here is we have 900 symbols as our main benchmark. So let's just insert 9 symbols. So 10% of it. This is very naive thing, like we are getting the first 10th percentile of this distribution. So it will be the fast access. For these, let's say, symbols, I could get like the latest symbols. So, but yeah, in the distribution, it will make a little difference. But these are things that you can also think. And if you see here, you can also see that we get like tracking 50% or tracking all the symbols, and then we can also confirm and understand how it goes. So I run this a few times, and like the results, I run with a few, like 20 million rows. I run, and the percentage is quite similar. So I was like, let me do like fast tests, fast iteration. So maybe I can even run it live here. So we can just keep it running. For example, /I benchmark trigger. So it will start running, and then we can confirm. And you can see here, for example, 3 seconds to insert with no trigger, and then 5 seconds with empty records, and so on. So I did it, and I will show you this in a more friendly table here. So varying from these steps and comparing to the version with no trigger, you can see that, for example, if you're tracking everything, it's 5 times slower than what you have, right? Okay, so it's 5 times slower, but have you checked the throughput of this algorithm? So it's really, really fast. So you are getting still a few 100 million rows like per minute, and maybe you not need to digest. And another thing that I would like to highlight here is the consumption. So for example, I'm going to just open here. This is my Timescale Cloud version. I will just refresh here, and then you can see here that I need to show you overview here. So I'm just using one CPU here, and with one CPU, like I got just one peak of 100% here, but it was not 100%. It was 60% of one CPU to insert 500,000 rows in 3 seconds. So or 6 seconds with all the updates and tracking all the symbols. So and 10 seconds for tracking everything, and it's still not using the 60% of this, 70% of the CPU here. So it's very small, and that's a thing that maybe you can also think that even like it slows down everything, it's still fast and good enough that you can just leave it as you want. So that's one thing that you can keep in mind. And going further, these previous tests, just to mention here, as I was using 8 CPUs, but I was all like monothread system, so I don't need 8 CPUs. So I could just use one CPU, and it was like almost the same thing, just like a small difference because the CPU is also smaller, like the size of the CPU was smaller. So it's a very, very good throughput, even with a single CPU, 4 gigs of RAM, and so on. And if you check, like you can go further and explain the updates and understand what is the cost of this update if you need to go further and narrow down. For example, is it using my index? Like you can see here, like bitmap index, and you can also see index in count here. So you see that you are optimizing, you have the right indices there, and then you can also narrow down your case and make it better as you need. And now let's talk about alternatives. If you are not really on real time, or like you can also create a candlestick of a few seconds, or even like in a second base. So for example, if you just have a fixed time bucket, even if it's a second, then you have already a fixed amount of chunks that a fixed amount of rows that you need to deal with. So it doesn't matter if it's second or minute, but soon you have it, then you know exactly how much memory you are going to need for everything. The problem on like undeterministic number of events is that you keep going further and further. So and it's unpredictable. So the main idea here is maybe you can just create some background process that runs every 5 seconds or every 3 seconds or every second, and you keep everything materializing, and then all the reading access is redirected to this materialized view. So you never like be looking for the same resources from the stream again. That's it. Another alternatives. So another alternatives is continuous aggregates filtered by symbol. I would like to call attention here. For example, let's say for example, you don't need to track all the things. You just need to track a subset of things. So in this case, you could go and cluster or cluster them in continuous aggregates with a subset of things that you really need to watch, or you could go and think about clustering them in similar sizes. So for example, if you have high throughput in, let's say, Bitcoin or Ethereum, like they have much more transactions than other markets. So maybe you would run them in another stream that will use like a 5 seconds continuous aggregates that uses this concept. But for the rest of the things that are just like with a regular amount of events, you can just run them isolated. So maybe you need to do some programming in the middle and have like this middle layer that you can divide and conquer, and also cluster things that make sense, and in terms of sizing, and also in terms of life cycle, because maybe you will be compressing things different, or even recycling data more often depending the symbol. So it's always a good idea to think about creating these categories of life cycle, and also like understanding the density of your data so you can better mix this. So another idea that I really want to try, I haven't tried yet, is using notifying. So notifying can be a very nice way to broadcast things back. So instead of making the trigger do something, let's say, that touches the database, it can just touch the broadcast and broadcast some message back. So that would be, for example, oh, latest price crossed the high of a candlestick. That's something that makes sense for you, and then you can also notify back like a trading signal, right? So that would be alternatives, and also things that we can explore in future versions. And if you have any ideas, or if you build anything, I would love to have your comments in the chat. Also, I would love to discuss them live. If you want, I can also pass the mic. We have a few minutes, and we can continue talking about it. Okay, so benchmark scenarios can help. So this is a very small backslash timing, very primitive scenario, but it still can give us some direction of like how much something costs, and can I afford the price of this performance change, right? So it will always be helping. So every time you are building something, just try to see the figures and see how how much you can cover with a simple function that emulates something, so you know how far you are from like abusing the CPU or going to the maximum or like hitting the limits of the machine or like needing to do architectural change. So this is very small one, but I hope it can inspire you. And if anyone has any questions, I'm happy to answer live, or we can also address them async. Okay, it seems we don't have any questions. In this way, just a reminder, we will continue. We have still 3 sessions about finance, and I would love to have any discussions about this, about the progress. If you want to go and also give me a feedback or reach out, I'm very happy to discuss and improve these sessions based on feedback. In the next session, we are going to talk about tracking pair correlation, and I see Nelson is on this call. Nelson is building like a correlation rating system, very cool. I will check with him if we can present this in the next meeting, and I will also be presenting some other correlation ideas. So we are going to talk about how we can bring like a pairs correlation to the database level. So if you are curious, you can check this out. We already have it implemented in our template, and we are going to walk through here and discuss the pros and cons of everything. So our discussion continue in the discussion finance market data. Also take a look on other discussions that we are having there. We have discussion sensors that we will start next week, and feel free to join as well. So thank you very much. Also, a reminder that we have the office hours. So if anyone would like to have a call, a one-on-one call with me or James, we always, and the DevRel team always wants to have this type of like conversations and go deep in your technical background, or what do you need for getting success with Timescale. And we are very happy to help. I have these calls every week, and I love these calls. So I'm always happy to have more and more of this, and I'm always learning with the community folks as well. So thank you very much, and see you next week.